So this section is about myth busting, and it's going to go in two parts. The first part is going to be about things which are good in themselves, things which we should be doing, things which are valuable, but on their own, they are not solutions to the crisis. So these are things like the circular economy, plastic and waste reduction, the sustainable development goals, and so on. And these things, they are good in themselves. They are part of the incremental changes that we have to be making. They are part of the solution, but they leave so much undone and so much unsaid. And when you add this all up, you come to concepts like green growth or, as I just mentioned, sustainable development. But those concepts, although they look good, it is very questionable whether they're at all possible, because they don't address the fundamental problem, which is growth on a finite planet. And this thing has to be put on the table. And if we don't put that on the table, then we can believe that those kinds of actions and those frameworks for development are going to be good enough. And clearly, when you think it through, they aren't. They are part of the solution. They're important components of the overall solution, but in themselves, they don't get there. And it's that missing bit which we need to inform our students about. And it's that gap which is really interesting to explore, because inside there are some really deep questions about humans, about what we actually want, and questions of identity and purpose. And when you start to get into that zone of thinking, then all sorts of things open up. And in the second section of myth busting, we'll be looking at concepts which really should come with a health warning. Things like carbon offset, the idea of net zero by a certain date, or even carbon capture. And the point of these two myth-busting exercises is to give the students and teachers a map, a clear map, so that, in the words of the GreenComp framework, the students can navigate the political system. It goes on, it says, and identify political responsibility and accountability for unsustainable behaviour, and demand effective policies for sustainability. At the moment, all the policy frameworks, all these macro kind of agendas with these green names and green initiatives, they're all very good, but they don't provide a clear map of the wider, bigger systems problem. It's an uncomfortable thing to talk about, but it is just true that you cannot have infinite growth. And the political systems which we have and the policies that we have are fundamentally unsustainable, as will become clear through this myth busting. So let's get on with the myth busting. So the best place to start with this debunking is with a chessboard. And we're going to put 1 grain of wheat on the first square and 2 grains of wheat on the second square and 4 grains of wheat on the third, and then 8 and then 16. And by the time we get to the 64th square, there would be, if they would fit on, 18 quintillion grains of wheat. And that is equivalent to 2,000 times the annual world production of wheat. What this image shows is that exponential growth can be huge, monumentally huge, in a short compound space of time. Let's switch from wheat to population. So for example, if we take an average population growth of 1.3% per year, it doesn't sound like a lot, but if that continued from today, in 780 years, there will be 1 person per square metre on the dry land surface of the Earth. Now, of course, that would be utterly impossible to live, because out of that 1 square meter, you would have to have your food, your water, your hospitals, your schools, etc. And it's inconceivable that we would ever get to that position. And in fact, you don't have to reverse that many years to find that population growth is already exerting an enormous pressure on the Earth's systems. So it's not 1 person per square meter, but the actual stress on what the Earth can produce is already way over what its carrying capacity is. And of course, that's not equally distributed. That's mainly from the high consumptive rich nations of the world that are doing it. And the point of this population figure is simply to show that you cannot continually grow. It's just not possible. Let's just roll that out with numbers with GDP. So let's take the year 2000 as a starting point, and let's grow the economy by 3%. That means that by the end of the century, the economy would be 20 times bigger than it was in the booming 2000. And if you keep going another 100 years, it's 370 times bigger. And another 100 years on from that, it's 7,000 times bigger. And that is just a 3% growth rate every year, year on year. But this is the problem, that in terms of the current paradigm, that's what economies and politicians are pushing for. And that's been okay up to a certain, that could be okay up to a certain point, but now we are well beyond the carrying capacity of the Earth to afford that, to sustain that. We are already running into planetary boundaries. So look at this graph. In this graph, you can see that we are already way over what is a sustainable limit. So the sheer tonnage of consumption of resource extractions has already been far exceeded. And imagine by 2050 what the rate is going to be. So we're pushing for 3% economic growth, and what that carries with it is this enormous load on the planet. And if you look at the Cut-X index numbers, not this time for climate change emissions reductions, but for resource extractions, you can see that the 7 ton per person limit, which has been defined by the International Resource Panel, at the moment, most European countries are way over that. So, just an example, Belgium, 33 tons per year and increasing. The Netherlands, 32.3 tons per year, also still increasing. Sweden, 26.7 tons per year, going up by 2.5% every year. So in terms of, if we're talking about green growth, that this is the bottom line, these are the fundamentals to what happens when we grow the economy which relies on resource extractions. And those resource extractions are the primary cause, the overwhelming cause, 90% in fact, of all biodiversity loss. So this is the fundamental thing which is not addressed by things like the circular economy. Because the circular economy is simply recycling plus plus plus. So it's a very advanced form of recycling, and of course it's good, but it doesn't address the fundamental problem of growth. So let's just take, for example, the construction of a motorway or a road or a house. So every year, 27% of the economy is, you can't make it circular. You can't bend it to be circular because you need those new houses and those new roads and that new infrastructure because the economy demands it. So let's say that we were totally successful with the rest of the circular economy. That's still 1% of growth, which is still pushing us forward towards these planetary boundaries. Now, if we consider why we are doing this resource extraction, one of the main reasons is for energy, because we need to build more solar panels. and we need more batteries for our cars and things like that. Now, the World Bank in 2017 had a look at the basic numbers and what would be required. How many bits of silver, how many bits of copper would it require for the whole of the economy to be greened by 2050? And the results of their research are kind of mind-popping. So we would actually need 34 million tons of copper, 40 million tons of lead, 50 million tons of zinc, 162 million tons of aluminium, and no less than 4.8 billion tons of iron. And lithium is another example of an extremely difficult resource to mine because it takes 500 million gallons of water to produce a single ton of lithium. So even the process of extraction is intensive, and the more that we mine, the more difficult it gets to find adequate mines. You have to dig a bit deeper. It's a bit harder. They're in smaller blobs. And so the whole process of trying to extract this stuff gets more and more problematic, more and more energy intensive, and of course more and more biodiversity destructive. If we step aside from the problem of resource extraction and the fact that the circular economy and recycling is just never going to be able to absorb the overflowing demands and increasing demands that our consumption and population growth are going to require of the planet. And if we turn to efficiency, it's another idea that we can just reduce waste, make things more efficient. Well, I'm going to quote now from the book Less is More by Jason Hickel, and he's a leading thinker in the area of degrowth. And of course that title might trigger negative feelings or negative thoughts, but the problem is that these are just mathematical or physics. If you look at the second law of thermodynamics or entropy, this is just the simple facts of living in a closed mass system. We live on a limited Earth with limited resources and with a limited carrying capacity. So at some point we cannot keep growing. So therefore we need to do some degrowth. This is what he says. So back in 1865, during the Industrial Revolution, the English economist William Stanley Jevons noticed something rather strange. James Watt had just introduced his steam engine, which was significantly more efficient than previous versions. It used less coal per unit of output. Everyone assumed that this would reduce total coal consumption. But, oddly enough, exactly the opposite happened. Coal consumption in England soared. The reason, Jevons discovered, was that the efficiency improvements saved money, and the capitalists reinvested the savings to expand production. This led to economic growth, and as the economy grew, it chewed through more coal. So if you look at a house, a more modern example, you look at a house in the 1970s, there would be one light bulb, a pretty inefficient light bulb. If you look at a house today, they have LED lights which are incredibly efficient. But the house probably has 500 LED lights, and those LED lights carry with them a lot more resource extraction. So every time you get an efficiency, you get what is called the rebound effect. Or if we really go for the very unmemorable title, we could also call this the Kazum-Brooks postulate, after the scientist who also framed this paradox. So for those people who want to imagine that innovation can save us, or that technology will be able to, in a way, magic a solution, then again, it doesn't address the fundamental problems of physics, that this, again, is a limited Earth, it's a limited space. So, one last time, in terms of myth busting, the notions of sustainable development, of green growth, of the circular economy, of waste reduction and efficiency savings, these things are not bad in themselves, they're essential to the new economy. But the problem is that when people use those terms and they use those phrases, they don't use them with the embedded understanding of the background problem of growth. And that is why they are misleading. So just as you need buoys in a beach to mark out areas where the tide is dangerous or where the rocks are hidden, we also need to flag and identify these key hidden dangers which are not apparent on the surface of these good concepts. To sum up just how inadequate the circular economy is to cope with the background forces of our economic development, I think there are three really telling statistics. The first concerns plastics, and that is that an OECD report estimated that plastic waste is set to triple from current levels by 2060. So despite all the attention that we have on these individual actions, and despite all the media attention with, shopping bags and things like that, it's still in line to triple in 40 years. Secondly, if you just put the numbers onto the curve that we looked at earlier with the resource extractions bending upwards, the thing is that towards the end of the curve, you have much more additions each time. In fact, the United Nations has estimated that in the next 35 years, our resource extractions will equal the last 300,000 years of our time as Homo sapiens. So in the next 35 years, we're basically going to double what we have done so far in the entire history of humanity. So our manufacturing power and our consumptive lifestyles have got this background pressure which simply would outweigh any attempt to diminish that impact through the circular economy. And finally, just to provide two more statistics. Since human civilization began, plant mass has declined by 50%, and only 17% of all wild mammal mass remains. Essentially, we've practically reduced the natural world down to just a few urban cats and dogs. And so we come to the second set of myths to bust. And these are the ones that really do come with a health warning. So let's start with net zero. First of all, the problem is that when people use the phrase net zero, it's always attached to a date, but that date is arbitrary. 2050 or 2060, there's no reference to the actual requirement laid down by the laws of physics and chemistry. These are just political dates of what is politically conceivable. The second problem with net zero is the word net. The problem with the word net is that most of the carbon capture schemes which are out there are actually just junk. And I will let John Oliver explain that more fully in his, you can find it on YouTube, the link is available in this course. The problem is that net is an accounting idea, and you can put into a spreadsheet all kinds of things that are not really rooted in real life. Of course, I say this off the top of my head, but if you imagine that everybody who ever gets in a plane would have to plant 10 trees to offset the carbon, then you can imagine that the number might well exceed the total land surface of the Earth at a certain time. So in a conceptually, there may be a balance between what you're doing and what you might offset it with, but can the Earth actually carry that amount of offsetting? The other myths that really have to be pushed firmly to the side are the myths involving political commitments about climate change, which are framed as X reduction in emissions based on Z year. And this has already been covered in the previous module, but these are so ubiquitous. This framing of the crisis away from scientific reality is the thing which on the surface it looks okay, but it's actually just a junk way of going forward because it's not informed by the real world. So we're going to send our students into the democracy, into the civic space, to have an impact with leverage. Then we have to give them a clear map. These things are a little bit difficult to handle. Being able to spot the difference between a half-truth and a quarter-truth, or sometimes just the outright lies, it's a difficult exercise. So we have to give them a clear frame of reference with which they can measure things. And that's really the importance of the CUT-X index, which the Climate Academy uses. It provides a really simple one-digit way of measuring a country's emissions and resource extractions, and you can hold them accountable in a very simple way. Everything is embedded in those numbers. They are fair, they're transparent, they have simple calculations behind them, and there's no distorted algorithms or sneaky accounting tricks underneath the surface. The numbers are endorsed by the world's most eminent scientists, and so therefore the student, when they use them, can speak with real authority, with scientists on their shoulders, about what the truth is and how close we are to these various planetary boundaries.